Oh well, this is the latest incarnation of my hot air or Stirling engine. It has a number of improvements on its predecessors. First of all, the combustion chamber, the displacer containment chamber, has been made larger to make it more compatible in the volume with the volume of the power cylinder. Also, it's made from more thin-walled material, so it's conduct the heat poorer, so there's a less conduction of heat from the hot to cold area and vice versa. It also warms up faster because it's being more thin-walled. I've got much larger radiator around the place. Some things are still the same. I still have my virtual magnetic spring enabling the displacer to levitate inside the displacer chamber, and because it's all natural resonance as before. I have the same crankshaft and the flywheel. I've got a new electric generator which is pulled out of hard drive. The motor of which this generator is made is a three-phase AC, so I had to make a rectification circuit to feed it, to load it into a set of LEDs here. There are 20 of them there, connected in parallel. The rectification circuit is a normal diode capacitor tripler circuit. The biggest improvement of them all, which I come across accidentally, is the diameter of the connecting tube between the displacer cylinder and the power cylinder. In the all predecessors, the connection tube was a brass pipe with internal diameter of about 3 millimeters. I always thought that it's best to keep this diameter small because it's a dead air. It's not swept by either power or displacer cylinder, so it detracts from the power of the engine. But quite by accident, I inserted a larger tube of about 5 millimeters diameter and noticed a marked improvement. I mean, 2 or 3 times improvement in the power. And it made me realize that even though there's a bigger dead volume inside that pipe than inside the 3 millimeter one, the larger diameter allows much freer air passage between the two cylinders. So the air viscosity doesn't slow down the engine. Before, I thought that, I even commented out in earlier videos, that the RPMs are being restricted by the natural resonance of the virtual spring. Now, it's still the case, but this natural resonance of the virtual spring is much faster. You will see when I light up the engine that it moves much faster than it was before and produces much more power. That's enabled me, by the way, to load it into 20 LEDs instead of 5 as the previous version were. Okay, well, the next stage would be we light up our engine. Okay, let's get it going. Light up the burner and put it underneath. Immediately you see that the flywheel starts moving a little bit. That's because the displacer cylinder is very thin-walled and heats up fast. It's moving to the extreme dead point. We'll force it a little bit back so it gets another one. Let's continue moving and warming up. Due to the air expansion inside, of course. We'll force it back again. It's still expanding. I would suspect it's probably warm enough to run on idle. Yeah, it probably is. Let's give it a twirl. Now you can see what I meant by the comparative speed of its movement. It was never reaching this type of RPMs before. And it's not really warm yet. Well, it's obviously warm enough to run by itself, but if we put a load on it, you will see that it's not quite ready. Let's apply load. See, it's slowed down. It will take another 2 minutes or so before it's ready to drive a load. It's not ready yet. So what I'll do, I'll stop the video and I'll resume it in 2 minutes time. Okay, 2 minutes or so have expired. Let's try give it a twirl, see if it will be warm enough to drive the load. Oh, it drives it quite happily. You can see the LEDs are shining, all 20 of them, and it's going quite smoothly actually. And still maintains a pretty reasonable RPM, even though it's loaded. You can see the generator is now connected to the flywheel by friction and produces electricity. My guesstimate of the output power will be about half a watt here. You can't solve the world energy crisis with that, but some small step forward will, I guess. And it goes quite happily. Just this nice pumping noise. Stirling engine is real poetry in motion type of device. It's quiet, you can talk. I mean, imagine me talking over the noise of the internal combustion engine. It would be next to impossible. Here is no problem. So we've got a Stirling energy generator here right now. Okay, what we'll try to do is to reduce the power a little bit by making the wick smaller. See what effect it will have. Well, still going. At pretty steady RPMs. It's obviously hot enough. Make it smaller still. Now it's struggling. Yeah. Not enough heat coming out of this smaller wick, so it can't drive the load. But if we remove the load, unload it, and give it a twirl, you can see what crazy RPMs it goes to when run on idle. At the tiniest of flame. A great improvement on my previous versions of the Stirling engine. Okay, well, that's enough. I'll take the heat off. Being thin walls, it's not only warms up fast, it cools down faster, so it will stop pretty quickly. Oh well, here it is. A free-piston Ringbom Stirling engine. End of story.